In this presentation, we're going to discuss calculating average communication rate in people who use AAC. This presentation is going to use a number of short clips that were recorded for different classes at different times. So I apologize in advance if audio quality is variable. If you ask people who use AAC what they value in their communication, they will tell you they want to be able to say exactly what they want to say and say it as fast as they can. Measuring average communication rate helps speech-language pathologists get a better idea of if they are helping their clients say what they want to say as fast as they can.
Now, to start with, many performance measures from language data are measured using language sample data collected when the client is using their AAC system. At this point, many devices and apps from many manufacturers have built-in data logging functions that can be used to collect a language sample, which looks like a real-time transcript. I'm presenting this on the assumption that you're going to have a system that's able to do that. If not, you may need to get creative and use a timer and perhaps collect a continuous sample like you would from someone who is verbally speaking. So going into the menu, just to show you, on New Voice, if you open the Review Vocabulary menu, there's a piece here that you can turn on data logging, and that will let you turn on a feature to collect a language sample.
In the AAC field, the paper that defines communication rate measures is this paper by Romich and Hill from 2000. Romich and Hill outlined a procedure for calculating average communication rate that is very similar to the procedure for calculating communication rate in clients who speak verbally. The goal was to create a measure that was as comparable as possible to the measure used with other clinical populations. So you'll see that the computational formula for measuring average communication rate in clients who speak verbally is very similar to the computational formula for measuring average communication rate in clients who use AAC, and there is only a small adjustment that is made to address a specific challenge. When you are working with a client who speaks verbally, average communication rate is measured in a continuous speech sample, which may be collected using a picture description task, a standardized reading passage, or any other method that allows you to collect a continuous speech sample. Average communication rate is measured in words per minute. Using this method, the clinician counts the total number of words that the client produces in that continuous speech sample and the number of seconds it takes to produce that speech sample, and then calculates communication rate by dividing the number of words by the number of seconds, and then using a conversion factor to change the unit of measure to words per minute instead of words per second. Average communication rate is a very useful measure for many clinical applications with clients with different clinical profiles. It's helpful for understanding what's going on with clients who have different types of motor speech disorders. It's helpful for understanding a little about what's going on with clients who have fluency disorders, and it's helpful for understanding clients who use AAC. In all of these cases, measuring average communication rate helps you understand how efficiently the client is communicating. This is an example. One way of collecting a continuous speech sample is to use a standardized reading passage. And here I have a standard reading passage that many speech-language pathologists are familiar with. This is the grandfather passage. A client may be asked to read this passage out loud, and the passage may be used for measuring many different speech characteristics, including average communication rate. So I read the grandfather passage out loud in a continuous speech sample. It's a 131 word passage, and I read all 131 words in 54 seconds. As I was reading, I slowed down a little bit to put some emphasis on certain words, so my communication rate might be a little bit slower. And using the computational formula I presented, we can determine that my average communication rate for this reading of the grandfather passage was 146 words per minute. Now there are some particular challenges that relate to collecting language samples from clients who use AAC. One particular challenge is that the communication rate is slow. This is one of the biggest difficulties with using an AAC system, so it's a real challenge to address. And because communication rate is often much slower than you see in people who speak verbally, production is not continuous. It's very difficult to collect a long, continuous sample of language generated by a person who uses AAC. Romich and Hill addressed this problem using log file data, and they pulled information from the log files to measure communication rate in individual utterances, and use data from individual utterances to measure average communication rate across the whole sample. So in order to do this, the information they needed was the starting timestamp, which would be the timestamp of the first event in the utterance, the ending timestamp, which would be the timestamp of the last event in the utterance, the utterance length in words, and the number of words in the first language event. So in this measure, that's looking at the communication rate in an utterance, you'll see that this formula is very similar to the formula you saw for average communication rate in a spoken language sample. The difference is that we see this is looking at the length of time used to produce one utterance. So we see the ending timestamp minus the starting timestamp of the utterance in seconds is the denominator. And the numerator is the number of words in the utterance that are produced after the initial language event. So it's the total number of words in the utterance minus the number of words that are produced in the first language event. So Romich and Hill are using that initial timestamp as the starting point and measuring everything that happens after the initial timestamp. Now, it's important to note that given this computation, pre-programmed utterances are not included in analyses of communication rate. In a pre-programmed utterance, the entire utterance is produced in a single language event, which means that the ending timestamp and the starting timestamp are the same, and the amount of time that's used to produce that utterance is 0. At the same time, the total number of words in the utterance and the number of words in the first language event are also the same. So that would be dividing 0 by 0, and that really does not count towards any computation, even if you do want to transcribe it. Now, to compute the average communication rate in a language sample, Romich and Hill add the total number of words that are included in analyses of communication rate for individual utterances and divide that sum by the total amount of time used to produce those utterances. So there's adding up the sum of the words in each utterance, adding up the duration of each utterance in seconds, and then converting from seconds to minutes. Okay, so now that we understand how average communication rate is calculated, let's actually run through a calculation with some data. I have two files up here on my screen that we're going to work with. The first file is a lamb log file that was generated on New Voice Pass software. I generated some spontaneous novel utterances on an AAC system and recorded a log file. You'll see here as you go through the log file, there's a series of lines where there's a timestamp and then some information after the timestamp. What we'll see is the ones that I'm going to have you ignore for the time being. These events where there's a timestamp followed by this code LOC. Those incidences provide information about the keystroke. What button did the client push to generate when they were making selections? What I'm going to have us look at is these language events where there's a timestamp and there's a different code followed by something inside straight quotation marks. These events are language events that record a log of the output on the device. And on older devices, these are the only events that are reported. So we're going to focus on these. And as you can see, each time an output is produced, it records an event like this. And in this case, there's also a code that says what was the language representation method used to produce that particular word. In this case, I said the word what using a semantic compaction, and it was at 1:34 p.m. and 30.786 seconds. There is an utterance, as you can see. It reaches the end of my utterance, and then in this case I cleared the screen. Clients don't always do that, but you should be able to identify utterances the same way you identify utterances in spoken language. And it says, what do you want to do today? Okay. All right. Now this file is a communication rate calculator that I created on an Excel spreadsheet. I'm going to have the full text of my log file posted in the YouTube description. I'm going to have an explanation of how to set up this spreadsheet posted in the YouTube description. So if you want, you can create your own communication rate calculator, and you can use the sample log file to run along and make sure everything calculates okay, based on what I have on my screen. So in the first few columns here, I have spaces where I enter my data. So here's the utterance. What does the utterance say? And it says, what do you want to do today? Now, as we saw, this utterance is 7 words long. What do you want to do today? 7 words. And as we saw in the log file, the first language event was a whole word right here. And I said the word what. So my first language event has 1 word. Okay. And that automatically calculates over here that there's 6 words that are used in my communication rate analysis for this utterance. Okay. Next, I'm going to come in and I'm going to copy the timestamp from my first event into my starting timestamp. Okay. And this ending timestamp will be the timestamp for my last event, which is the word today down here. Okay. All right. So as you see, when I put my 2 timestamps in, my starting and ending timestamp, I get a calculation that this utterance was generated in 0.54 minutes. And then that calculates my communication rate for this utterance, which is 11.08 words per minute. Right now, on the far right, it says my average communication rate is the same as the communication rate for this utterance because it's the only utterance in my sample. Okay, I'm going to pause the video recording and analyze a few more utterances so that I can come back. You don't have to watch me do all that work. And you can see how my analysis for those utterances contributes to the overall measure. Okay, so I've analyzed 4 utterances here for you to take a quick look at. Here, what do you want to do today? It's the first utterance we worked with. Second one, I want to get breakfast. There's a 5-word utterance with 2 words in the first language event. And if you go down and look at the log file in the description, you'll see that there are some maze words at the beginning of this utterance that I'm not including. So I'm only analyzing the final output. This is another sentence. We could get pancakes at Pamela's, which is 6 words with 2 words in the first language event, and the word Pamela's is spelled. And then finally, I've included a pre-programmed utterance, thank you, which is only 1 language event, so there's only 1 line, and you'll see everything happens in the first language event, so it comes out as really not contributing to my measure. Now, my overall average communication rate is the sum of this column, right? So we can see the calculation here. The sum of these words that are included in the analysis divided by this total time here. So we have words divided by time, and it's added up from these columns to give us average communication rates. Take a look, and this should give you some good examples to work from. Good luck running your own samples.